Okay, so here's the worksheet I want you to do right here. And we're just going to go through number 6 together in class. So the question says, 100 feet of fence is used to enclose a rectangular garden. Let X be the length of the side of the garden. Kind of hard to get your mind around that, so I'm going to draw a rectangle. There's a rectangular garden right there. It says let X be one side of the garden. Does that work? Good enough. But in a rectangle, if that side's X, that side's X. Everybody with me? Okay, all the brilliant people in this room, somebody tell me how long this side is right here. 100 minus 2x is pretty good. It's not quite, because I asked how long this side is. There you go. Half of 100 minus 2x. Okay. Since the whole thing's 100, if you took these two sides away, 100 minus 2x, that's how much you have left for these two, right? So if you take half of 100 minus 2x, you get, don't you? Agree with that? And this side would also be 50 minus x? Alright, is everybody in the room with us? Okay, A says write an equation for the area of the garden. The area. Area of a rectangle. Let's see, that sounds like, I find the area of a rectangle. Length times width. We all knew that. So here's letter A right here. Letter A, the area of the rectangle is going to be the length times the width. How about x times 50 minus x? Are we good? B says draw a graph. Alright, well we can do that, but I'm going to do it on the grapher. Before I hit enter, what are we going to expect this graph to look like? Oh, I heard it. What? It's going to be a parabola. I'll never get that way. There's no x squared in that. Of course there is. What this really says is 50x minus x squared. Now, it's a parabola because it's x squared. Parabola going up, down, right, left. Gina says down. Why? You got it. It's an x squared. X squareds are up and down. Plus, you know, this whole chapter we're talking about functions. I mean, that's not a function and that's not a function, right? That item would have two prices. So it's either going to go up or down. Gina's got it. Negative means it's going to go down. Now, it's important you know that. It's important you know that it's a parabola going down. Otherwise, the graph's not going to make any sense. So here it goes. Enter. What? I know parabola. Really all I see is this little line here. What in the world? Explain what's going on. What's that? Sure is. It's a really big parabola. We're only seeing one side of it. So it's very important that we know it's a parabola going down. Because see it, how the parabola is just a little bit on that side of the axis over there? And it's just a little bit on that side of the axis over there? And the axis is the one that has the tick marks on it. So since it's on that side over there, and that side over there on the top, where's the parabola?
That way.
Yeah, exactly. That was hilarious. You all pointed like that together. It's way up there, maybe like that somewhere. So I'm going to go adjust my window. Now, if I didn't know that, so I had to come in here with a lot of knowledge. If I didn't know it was a parabola, if I didn't know it was a parabola going down, I wouldn't know where to search for the rest of the graph. I wouldn't even know there is more graph. So I need to go out that way. So I'm going to go up here to the top to view, frame limits. Well, we don't really need anything back to -5. We could go just to like -1 or something. And let's try to go out on, I don't know, to 20? See what happens there. Still not there. 50? Okay, let's try it. What did you say, 50? 50. Let's give it a shot. No?
Might have to go with 100.
100?
Can we just put infinity on it?
Aha. Ah, it was on 50. Yeah, the problem was when we went right to 50, it was just right up against the edge, so we couldn't see it. So actually, like 55 would do it. Just give us enough room to see it, so let's go. There we go. Okay, so there's the parabola, but now we gotta find it going up. So that would be, will you tell me, which one of these do I need to change to find the parabola going up?
Second one.
Yeah, the second one. That's the down. We're fine down. We need to go find it going up. I don't know. If it goes out 50, it probably goes up.
735? Golden exact number.
In honor of helping, 735.
Oh my.
It's possible. It's possible.
Usually people start with 500, and you can see when you go at 500, it would have just been cut off right there. And that would tell you just go up a little bit further. 735 works. Okay, there's our parabola. Okay, so B is done. There's the graph. Now back to the worksheet. Letter C says find the domain and range. All right. So on B, there's nothing to write on your paper because it's on the graph. We don't understand that. C, the domain. Okay, let's go.
On B, do you just want us to like look it up on the computer and find what it looks like then?
Should we check for our 1,50 like
Are you to answer B?
Yeah.
No, you don't have to write anything down on B. I know you will graph it correctly if your answers are right for C, D, and E, and you know, nothing to write down. Am I hitting that parabola right there, right now?
Mm-hmm.
Dang right I am. Way down to the ground somewhere, but I am. What's a domain? Sure is. Parentheses always go with the infinities, so negative infinity to infinity is the domain. All right, range be the same?
Negative infinity to
Am I
whatever
hitting the
that
graph
is.
now?
Yes.
No. Ooh, right there I'm not. So, it's negative infinity going down, but it stops somewhere going up. Whoops, that's probably a mistake. That's probably a mistake. Probably a bracket. Because it definitely stops at a definite place. Where? How do I know?
Local extremum.
So it's under equation.
Yeah.
Yeah.
Root, yep. Oh, I was doing something in calculus, so I don't want the root, I want the local extremum.
No, it's already got it.
It's already on there. So it's at
625.
25, 625. This point right here is 25, 625. Everybody with me? So what am I going to put in that bracket right there?
625.
Excellent. 625. When was it when we always used the X?
Max out
True. Remember me saying the other day we always use the X coordinates? Well, that's true. Good answer, Helvin. You always use X when you're find the domain. Y is the range, but also when we're doing increasing, decreasing. You always use the X coordinates. But you want to use the Y coordinate for the range. All good? Everybody? Okay. Letter D. All right, letter D says, what values of X would really work in the problem? Okay, here's what they mean. The domain, yeah, right, so right here's the values of X, negative infinity to infinity. Yeah, but not really. I mean, if we're really building a garden, first of all, there's a whole bunch of those that are ridiculous. Which ones? Why?
Because it's only
Feet of fence.
Yeah. You've only got 100 feet of fence to work with, so that's one of your restrictions. There's another one that I guess, that's a good answer. Something else I thought you were going to say first. Which of these numbers would be totally useless to us?
Negative.
The negatives. I mean, okay, go ahead and build the fence -2. What? I'm sure I can do that. So the negatives would totally be out. So let me put it this way. What is the smallest x could be? Theoretically.
Point 000.
Okay, I think with Braden, say that louder.
.0001.
Like 0.000. In other words, here's how I'm going to write that. Now, I suppose if you wanted to, you could probably have an argument here. If you say, well, no, you can make it 0. You can make x 0. I'm not sure you could, though.
Because you need time to turn around.
Right. I got 100 feet of fence. I'm going to start from this wall. I go this way, 50 feet. I somehow have to turn around to get back to that wall. So even if it's just a microscopic piece of a millimeter, I still have a little tiny width where the fence turns and goes back that way. That'd be quite a garden, wouldn't it? Two fences stuck up against each other. But mathematically, it's possible. So I think that's the right answer. Parentheses 0. Meaning, like Braden was saying, it could be .00001, but you're going to have just a tiny bit of width. Say it again?
Has to be above 50, doesn't it? The next part.
Has to be above 50.
It says if you plug in the x at the -50, you'll end up at 0.
I get what he's saying. I get what he's saying. But let's put that into use. What's the biggest that x could be? Look what x is in my rectangle. What's the biggest it could be? What, Tim? You're on the right track. I like the sentiment, but you're not. What's that?
49 parentheses.
Ooh, now we're getting closer.
50 parentheses.
50 parentheses?
I'd say 50 parentheses. Okay. Now I get what Tim was saying. He said you could go like 99.999. Problem is, if I start on that side and I use all 100 feet going this way, I can't get back. See, I can only go 50 feet so that I have 50 feet to turn around and go back. Well, of course, if I went exactly 50 feet and then used like a half of a millimeter to turn around, then I wouldn't make it all the way back by half a millimeter. Follow that? So that's why we need the parenthesis. I can actually only go 49.999999999 this way. Turn around and use 49.9999999 to get back, and that leaves like .0000001 for my little turnarounds. Quite a garden, wouldn't it? It says use the graph to determine the dimensions of the garden if the area is 500 feet. So now we know going in. This is now where upper level math is used all the time in engineering. This is how an engineer would do this problem. Say they have a request or a proposal and say you need to design the most rectangle that will give us exactly 500 feet of space. And so they need to figure out the dimensions that would do it. Now, most of us could sit down and say, make it 10 by 50. Isn't that 500? But is that the most efficient use of space? Is that the best way to do it?
Depends on
That's what an engineer has to figure out. All right, anyway, let's go ahead and do the problem. That's what it says. Use the graph, and we want 500 square feet. So, bring my graph back up. Well, 500, here's 250, and what's 500 right there? So I need to know where this graph hits 500. I need to know what that point and that point are. Are you with me? The find root has two choices. I don't think I need to put it in. You'll know this. It says find root,
You
or
can
local extremum.
do the find intersection.
You need to find the intersection. Yeah. The find root finds where it crosses the x-axis. The local extremum is the minimums and maximums. Well, that's not... Move that off there. These 2 points, they really aren't maximums. They're kind of random choices. So, hear what Braden said? We need to do find intersection. Find intersection of what?
500.
Find the intersection of what? Well, that graph, obviously, the parabola, but with what? Say it again.
500.
You need to find where it intersects 500. How in the world do you graph 500? What happened if I graphed the number 500? You bet it'd be a straight line. Looks like what? You got it. 500. Y equals 500. It's exactly what I need to put in. So, along with this graph, new graph, or new equation, y equals 500. Before I even hit enter, we're all going to expect a horizontal line, correct?
Yeah.
There it is.
Now you can do find it.
Now I have two
Intersect.
graphs that can intersect. So I'm going to click on both, shift click, and now I want to go to equation, and look at there, the find intersection lit up. See how it's highlighted? It wasn't before because I only had one thing graphed. How can you find the intersection of one thing? Find the intersection of Highway 71. With what? You need two things to find the intersection. Now it's got two, so I just click on there, find intersection. Gives me that box again. What do you suppose it wants? Why didn't it just give me the answer? You bet. This computer is kind of smart. Not real smart, but kind of smart. It knows there's two of them. It doesn't know which one I want. So let's look for the one somewhere around, what's that, around
15.
14 or something?
14. No, it actually is 14, I believe.
Right, we'll put in 13. It doesn't really matter. You just got to get close. If you just get in the ballpark, it'll find the one that you're looking for. Well, it turned out to be 13.8 and 500. I mean, that's 500 in computer talk. So, 13.8 is one of the answers, but there's another one. So I'm going to put and. Looks like 1 over by
36.
36? Okay, let's try it.
36.
36, enter.
196.
How about 36.18? Everybody with me? Which one of those is correct? Is it 13.8 or is it 36.18?
What's the question?
The original question said what value of x would give us an area in here of exactly 500 feet.
Either one of
We
those.
found two of them. We mean either one. You're right. They are, but how can they both be right? So if I'm an engineer, which way do I build it? Do I make it 13.8 or do I make it 36.18? Add them up.
It's like 50 miles.
If I choose 13.8 and make this side 13.8, then this side is 36.18. Now, we rounded this one to one place and that one to two places. That's why it doesn't add up exactly. And if we rounded that all the way, it'd be 36.2. Or I should have left that one out to two places so they would make exactly 50. I didn't think of that at the time, but it doesn't really matter. If I choose 36.18 for this side, then this side is 13.8. They're both right. That's the dimensions. You need to build this rectangle 13.8 by 36.2. And that would be the area, or that will give you an area of 500, I should say. Yeah, it does. Okay. Determine the possible values of the area, if the area of the garden is to be less than 500 feet. These give you exactly 500 feet. How can I make it smaller than 500?
Parentheses 13.8, parentheses 36.8, right?
No, but that's the right idea. Say that again, Helby. I'm right over here.
Parentheses 13.8 and parentheses 36.18.
Okay. It's not bad. I like what he's doing. Actually, as funny as this sounds, you couldn't be more wrong. But you're almost right. There's the right answer. Parentheses 0 to 13.8. Parentheses. What's the second part? Anybody?
0 to 36.
Nope.
Is it 36.18?
36.18. to
50.
50. What we just said right here, 0 to 50 is what we can really use.
Yeah.
Okay, so you see what I mean by Helbing couldn't have been more wrong?
Mm-hmm.
He had the part that you didn't want, the part you were leaving out. But look, it makes sense right here. Let me go back to the graph. Okay. This line is 500, right? We all agree? So it says, what values would give us an area less than 500? Be everything less than this line. So 0 to 13.8 right here gives you all this that's less than that line. From 36.18 to 50 right here gives you all this that's less than that line. Helbing actually gave us what was between, which was the only thing that was above that line, but his answer still proved that he knew what he was doing, didn't he? He knew it had to do with those, he just had the wrong side of them. But that was good. So had the question been reworded, what values of x would give us an area greater than 500? You nailed it. It'd be that right there. Right, just look at the graph, and that's what's greater than 500. Any questions? You guys don't seem that impressed, but you should be. It's kind of a tough problem. We'll just cruise right through it. Puts together everything we've done in the chapter to some extent. Okay, so when I said 6, 7, 8, 9, 10, it's only 5 problems, and we just did 6 in class, and eventually we're going to do 10 in class. We only have to do 3. Ooh, well, no, that's actually quite a bit to get that all figured out.